Hi everybody, Tiff Jensen with Research Methods. Back in my office again, trying to put some more concepts into place for you. Hopefully you're not panicking about this class. I know we're changing a lot of stuff, but I'm just here with you one step at a time, trying to make sure all the pieces come into place as well as they can. So I recorded a video about our stats review. Don't worry about what you may not remember or know. Not a big deal. So I'm trying to provide that reassurance that I promised you, and take one step at a time, one foot in front of the other, so that we can get after this really awesome outcome of having original research done in this class. So we're getting there. And some of you are maybe getting anxious, ready to start jumping into data. We're getting there very shortly, because I've learned this class can kind of turn into monkey see, monkey do. And you have to make sure you don't turn off your brain or your logic about how to do things. And you keep concepts in mind in the back of your head. It's going to keep you from making a lot of mistakes and from just copying what the instructor tells you to do, so that when I'm not there and you got to do it on your own, you have some tools to throw at this. That's the goal. So that way you become an independent thinker and really self-sufficient. So we're going to go into the research process, starting with the wheel of science. This is basically a watered down version of the scientific method. Okay, and there's a lot of ways to approach this. This is probably the most straightforward. Anytime we want to do research, we start right here at the top of the wheel with wonder. We wonder about something. How does that work? Why is that way? And we want to find out what's going on. After we start wondering about something, then we review the literature. Okay, now most people would go to Google and see what people know and say about things. That's not good enough for science. We go to science, which is highly tested, structured, organized, high standards, ethics, experience, and see all the studies and all the peer-reviewed journal articles which have been held to these standards, see what they know on the subject. And right there, we might get the answer to our question and go, oh, this has been studied at such and such organization, such and such university. Here's the answer. Okay, I'm done. Often that may or may not happen. So that might prompt us to go do our own research and go further in the wheel. So we may take this wonderment, find out what's been written or studied about it, and then end up specifying a question, going, how does A impact B and why? So it's going to make us set aside our phenomena more concretely and say, I think these two things are related. This behavior, this identity or attitude is going to predict this particular outcome or result, and I'm going to come up with a question that's going to hone in on my wonderment. And sometimes that question formulates by reviewing the literature. We go, oh, okay, so the fancy word for going back to drugs is relapse. Okay, I'm going to kind of use that word now to specify more concretely what I'm doing. After we specify a question, we develop our concepts. So if we're studying something like relapse, we might say, well, when we say relapse, what do we mean? Does that mean that they have to use the drug within 30 days? Does that mean anytime they use the drug? And does it have to be for a certain period of time? Or how does this work? Or certain drugs, okay? So that's when we start to go, okay, when I mean relapse, this is what I'm talking about. And really kind of, again, specify what we're doing. Then we come down here to theory, theorize. I realize theorize can be kind of a dirty word because people don't like theory. It's abstract and weird, and it's what those academic people do at universities, and I don't get it and I don't like it, and I'm a practical person, I'm a professional. You theorize every day. Anytime you come up with a grand explanation of the world and how it works, you're theorizing. That's it. Theory is an explanation. That's all it is. After we come up with our explanation of why we think we're seeing what we're seeing about what we wonder about, then we operationalize. Fancy word for measure. We need to try to measure or come up with a way of measuring how we would observe a relapse. Would we ask someone a question about it? Would we get data from a clinic or hospital? Would we use self-report where someone tells me, hey, I relapsed? There are pros and cons to how we would measure things. Some is going to include more behavior than others. So that's a big part of research is measurement. How do we measure everything to make sure that we capture the whole gamut? Okay, so we figure out how to measure stuff. We put an operation to it. Then we hypothesize, make a prediction. That's it. in a specific way. This is what I think is going to happen when I run this test that tells me if someone's going to relapse or not. And this is what I think the specific result is going to be. So theory and hypothesis, I'll tell you as an undergraduate, I couldn't tell you the difference if my life depended on it. Theory, grand explanation. Hypothesis, specific prediction. Okay? Lots of hypotheses make up a theory. So, but a theory, again, is kind of an overarching, larger explanation of what's going on. So that's one way to separate it. But again, I couldn't have done that as an undergraduate. I was terrible at this stuff. I've gotten a lot better at it over time. Observe. Now we're going to go collect our data, whether it's an interview, a focus group, a survey, an experiment, whatever. We're going to go get our observations and data, and then we're going to analyze. And you can analyze data in a lot of ways. Statistics is a very popular way, one we're going to do in this class. And we're going to run our tests and see if it happens the way we think it does, like we hypothesized. Then we assess and revise. We go, okay, I got a set of results. This is what I know. Was I right? Was I wrong? Maybe my question needs to change. It didn't turn out the way I thought it would. That's normal. You still got a finding. You still got an answer. But what you'll notice is, especially in science, once you get a set of answers, you also get a set of new questions. Then we're back to wonderment. Okay, so we'll go round and round this wheel of science all the time, coming in at different points. Maybe we're starting with theory. Maybe we're starting with a set of data, some observations. Maybe we're starting with wonder or measurement. It doesn't matter. This wheel is very flexible and just depends on what you want to know and where you're at in the process. But I thought this was kind of a very easy way to say, this is the path we're going to start going on, so you can think about what this will look like in the future. So we're going to look at two approaches, inductive and deductive reasoning. I'm going to move myself because I'm covering up my own stuff. So during the research process, deductive and inductive reasoning is used to reach a conclusion about the world. So people confuse these two. All this is an approach of how we're going to go about that wheel of science. Where are we going to start? There's different strategies, and that's inductive and deductive. You find out different things depending on which strategy you do. So let's take a look so we don't get confused. Okay, back up to the top. Deductive reasoning, it starts with the theory, makes a prediction, then we go observe or test to see if we are correct. So it begins with a general assumption and then goes out to a specific result or conclusion. So here's the example, and I'm going to read from the slide. You can follow along. People generally mature and stop committing crime as they age. I theorize that life maturity explains why people don't commit offenses. This sounds like that famous age-crime relationship that we studied in criminology. Further, I predict that 26-year-olds in my neighborhood aren't committing offenses like the 17-year-olds are. So this would be my hypothesis, my specific prediction. I'm going to ask each person about their offense history in the past year. This research method would be an interview, the way we observe and collect data. And then once we get all the interviews back, we say, aha, I can see that the 17-year-olds have more offenses than the 26-year-olds. That's my result from analyzing the data. And then we come up with our conclusion. I conclude that my theory of maturity reducing offending is correct. So this is a very traditional way of doing deductive reasoning. Okay? It's not perfect. Limitations. Okay? It is possible to come to a logical conclusion, even if that generalization isn't true. We can't apply it to everybody. So that means we can overstep or overgeneralize when maybe we really shouldn't. For example, here's an argument. All prison inmates have been convicted. Jose is an inmate. Therefore, Jose has been convicted. It's valid logically, but is untrue because the generalization can be false. For example, you can see an inmate and assume they must be convicted when they're not. Maybe they're awaiting trial and they haven't even been convicted yet. They're just in prison for safety reasons, for the community or for themselves, but it's not actually true. It can't be generalized to everybody. So our observations and data may be inaccurate, and so I'm here to teach you how to identify good data that doesn't have craziness or inaccuracies in it. It can be very difficult to do theoretical development with this because it's not really meant to do that. And our predictions may be a little skewed or vague depending on what we're trying to test. So we have to keep that in mind. Now we're switching gears to inductive. So inductive reasoning is the exact opposite of deductive. It starts with a result or observation, so a specific answer, and then makes a generalization about it. Then we go observe and test and see if we're correct. So it begins with specific, they determine a pattern, make a generalization, then you create a theory or an explanation. So for example, Harold is a recovering drug addict. Harold just relapsed. Therefore, all recovering drug addicts will relapse. We're kind of overstepping. Obviously, we can overgeneralize, but this gives us a good starting point for our quest for truth in the world. Okay, so sometimes we don't have much information at all, and we have to start this way. Limitations of inductive reasoning. We can come to the wrong explanation or theory on limited observation. So just because we observed Harold doesn't mean it's going to apply to everybody. The conclusion could be false. It allows for very little variation. It's just not representative for everyone. And we can't use it to test explanations or theories very easily. Okay? It can be used for theoretical development. Okay, but testing the theory this way doesn't work very well. So now we're going to do a mini test. We're going to see how you do on determining if this method is inductive or deductive, just by the nature of what it is. Here we go. So test yourself. Which method is inductive or deductive? So interviews. Doing an interview with somebody, would you say that's an inductive approach, perspective, or strategy, or deductive? Take a minute to think about that. It is inductive, okay? So again, this is letting the observations drive the general explanation or theory. Okay, let's try another one. Surveys and statistics. Would they be inductive or deductive? Take a moment. They would be deductive because we're starting with a theory or explanation, and then we're going to go get some observations to test and analyze in a survey, and then come up with a result. So surveys are generally deductive. So we're going to be using the deductive approach a lot more in this class than the inductive one, but both are critically important. Focus groups, inductive or deductive? Inductive. Okay, again, letting that data kind of emerge first, and then coming up with the explanation later. When you're in a room with people, you're letting all that conversation just kind of come alive. Here's another one. Ethnography. Remember, ethnography is living with people you're studying, embedding yourself in the community and observing their behavior and their lives and experiences, what they do. I call it kind of going native or going tribal. Inductive or deductive? Inductive. Okay, again, letting all those experiences emerge as you go, and then coming up with that grand explanation at the end. Last one, experiments. We haven't talked about experiments. We don't do them very much in sociology or criminology, but there are some. Inductive or deductive? Deductive. Okay, so again, this is where you come up with your question, your theory, and then you go collect the data to test the question or theory. And usually you have a group that receives the stimulus, a group that doesn't, and you see if there's a difference between the two groups. That's it. Okay, so rounding out the lecture, we can use both inductive and deductive. Okay, qualitative methods are generally inductive. You probably noticed a pattern there. And quantitative methods are deductive. Okay, so if you want to develop a theory, create the explanation, use inductive. Focus groups, interviews, ethnography. If you want to test a theory to see if your explanation is right, use deductive. Statistics, surveys, experiments. Okay, most social research use both inductive and deductive reasoning processes and strategies at some time in the project, trying to let one inform the other. Like we said, in the Wheel of Science, we come at this from different angles and in different parts of the circle. That's normal. So hopefully this starts to put into place what the whole research process looks like, how we strategize, how we're going to go get our question answered, and this was hopefully helpful to you. So more later on the research process, but we'll see you at that time. Thanks.